Hi there, welcome back to this channel. Now in this video, I'm going to be proving to you the Heron's formula. Now, let me show you the form of the Heron formula. There are two steps to using it to calculate for the area of a triangle. The first step involves solving for the semi-perimeter. Semi-perimeter, okay, and I'll tell you why it is called semi-perimeter. Denoted by S, and is equal to A plus B plus C all over 2. All right, then you now in the next step you now calculate the actual area of the triangle, which goes by square root of S into bracket S minus A, S minus B, and S minus C. Now it's very simple. Just stick with me till the end. I'm going to show you how to prove it. Okay. There are other methods of proving it. Okay, but I think this method of proving I'm going to use, you are going to understand it. All right. Now, it was named after Alexandria Heron, just for the sake of history. Alexandria Heron, who was a famous inventor and mathematician in the 1st century. All right, so how did he prove it? Now, you know that this formula is typically used for calculating area of scaling triangles. Okay, scaling triangle. It works well for scaling triangle. You know the general formula for right angle triangle, right? Which is basically half area of a triangle. Area of a triangle is what? Half base times height, isn't it? All right. So we are going to be using these also to derive it, but this time we have a triangle that is not a right angle triangle. I want to calculate the area. So let's say our triangle looks like this. Okay, scaling. This side is not equal to this side, is not equal to this side. So let's say we have A, B, C. All right. So this is what we're going to do. We will divide this, or we'll create a perpendicular to B downwards, right? So this side is going to look like this. So we have like two triangles here, isn't it? Two right angle triangles. Here I have A. Now let's call this side, let's call it B1. Okay? Then this side is going to be H, isn't it? And this side, we have a triangle that looks like this. Obviously, they are not the same. This would be like B2, and here C, and of course H again appearing, right? All right. So we know that this is 90 degree, 90 degree, 90 degree. All right. So we can now use the idea of what we know with right angle triangle, which is Pythagoras theorem, right? That opposite square plus adjacent square, is equal to hypotenuse square, right? So we have H squared plus B1 squared H squared is equal to what? A squared, yes. Right? Let's call this equation 1. And here also, H squared plus what again? B2 squared is equal to what? C squared, equation 2. But B1 plus B2 is equal to what? B. You know, yeah? This B is B1 plus B2. All right, so from here, the next thing we'll do is we solve simultaneously. We take care of this, right? So that by subtraction, so that we have B1 squared minus B2 squared is equal to A squared minus C squared. All right? This one is now difference of two squares. Difference of two squares. So how do you express difference of two squares? This is what difference of two squares is. If I have A plus B times A minus B, look how it will give me. This times this, A squared. This times this, minus AB. This times this, plus AB. This times this, minus B squared. So by this one will take care of this, right? It becomes 0. So we have A squared minus B squared. So it is such that anytime you have two squares, the difference of two squares, make sure you understand this concept because I'm going to be using it a lot. The difference of two squares is come quickly, come and help. Quickly. So This is the expression for difference of two squares. So I can say that this is the same as a plus b times a minus b. Is that one clear? More like if I have something like this, a squared minus 4, I can express this as a squared minus 2 squared. So this can be written as a plus 2 and a minus 2. You understand? So that's what difference of two squares is. So, and you need to know how to see when it has appeared, difference of two squares. You need to know how, when it has appeared. So we can use it here, but we'll not be using it here. There's a reason. The reason why we are not going to be using it here is we want to express this h in terms of the values we have. From the beginning of this thing, which values are we given? A, B, and C. We were the one that invented B1, B2, and H, right? So we want to write our expression in terms of just those things. All right. So if that be the case, then we have this difference of two squares means B1 plus B2 times B1 minus B2 is equal to A squared minus C squared. If that be the case, take note that B1 plus B2 is what? B. So we have B into bracket B1 minus B2 is equal to A squared minus C squared. Divide both sides by B. So B1 minus B2 is equal to A squared minus C squared over B. Now, if this is the case, recall again that here we said that B1 plus B2 is B. So if we put it here as B1 plus B2 being equal to B and B1 minus B2 is this, we can take care of this so that we can write this expression in terms of just B1, B1. Is it clear? You know what I did? These are our first equation here. We put it together with this one again. Okay? If we call this equation 3, this will be equation 4. Alright? So we eliminate again by adding. So if we add this, B1 plus B1 is equal to A squared minus C squared over B plus B. Make sense? So from here, 2B1 is equal to, LCM is B, A squared minus C squared plus B squared. So B1 will be equal to A squared plus B squared minus C squared over, there was 2B here, right? We divide both sides by 2. Make sense? So B1 will be equal to this thing. B1 will be equal to A squared plus B squared minus C squared over 2B. Alright, let's roll this as equation 5. Now we have gotten an expression for B1. We've gotten an expression for B1. Recall from the general equation that area is half base times height. And also from equation 1, where we have B1 and H. You know, we have an expression for, we have successively written B1 in terms of what we are given, A, B, C, D. Do you understand? What we are trying to do is make sure that in the equation we generate, B1 does not appear, H does not appear, B2 does not appear, because those are the ones we brought into it. This is what we're given. Is it making sense? Alright, so from equation 1, we know that equation 1 says that A squared plus B1 squared is equal to A squared. So B1 squared and B1 is this. So we have that, we can say H squared therefore will be equal to A squared minus B1 squared. Does it make sense? Alright, so this guy we are going to substitute. So we have A squared is equal to A squared minus A squared plus B squared minus C squared over 2B all squared. Do you agree? B1 squared. So B1 is this, so everything squared. Make sense? Alright, so since we have written an expression, we now need an expression for H. This is H squared. H will now be equal to take square root of both sides, right? So by the time we take square root of both sides, we have equal to square root of A squared minus A squared plus B squared minus C over 2B all squared. Is it making sense? Okay. So from here, we could, we will now bring it into our equation. Now, to write our area in terms of all these things now, since area is half base times height, and height is this, so we have area is equal to 1 over 2 base times square root of height is all of this, right? Square root of a squared minus a squared plus b squared minus c all squared over 2b. All squared also. You know the square is carrying, both of them are carrying the square. But do you know that this is an equation that we can also use? It's correct. This equation is correct if you want to use it to find area of a circle, the area of a triangle. Is it clear? Only that this is not the Heron form, and of course, again, another thing is this formula is harder to cram than Heron's formula. Look at it. This one is easier to cram, right? All right. So what we want to do is try and simplify this thing such that it looks like this. Okay? Is it showing that part well? It's not showing it. Remove it. Okay. Alright, so from here, I'll now say I want to simplify just this. I'll leave this for now. Okay? So it will become, or we may not leave it, let's write it. 1 over 2, I'm just trying to see if there will be space. B here, right? Yeah. Now see, I'm going to square this term. No. This term, if you square it to what? 4b squared, right? So we multiply this guy with 4b squared also. There's a reason. So that this thing will live here. Okay? So if we try it, it will give us, here, it will give us 4. What we'll do is we'll multiply this guy by 1. And that our 1 will be 4b squared over 4b squared. This is 1, right? So times a squared minus, then this place is left alone. A squared plus b squared minus c all over 2b all squared. This one 2 squared. Is it making sense? Alright, so from here, squared. From here, notice that 4b squared is now common under. If we write this as 4b squared, 2b squared, 2b all squared is 4b squared. Good. So it therefore means that this can become 1 over 2b square root of, I will take 1 over 4 out, 1 over 4b squared out. So if I remove 1 over 4b squared from here, to remain 4a squared b squared. Because if I multiply this, I'll get this back. Good. Minus a squared plus b squared minus c squared all squared. Is it clear now? Now keep in mind that there will be no denominator here again. Isn't it? Alright. So see what I'll do now. I want to bring this guy into this square root. Okay? I want to bring it to this family so that it becomes the square root of 1 over 2. No. If you bring this guy into a square root, you know it has to be squared. As in, it has to be 4 when it gets here, so that square root of 4 will now be 2 outside. Make sense? Alright, so it will be b will also be squared, so it will be b squared over 4 times 1 over 4b squared multiplied by 4a squared b squared minus a squared plus b squared minus c squared all squared. Is it making sense? Keep in mind that this guy on its own, so there should be 2 brackets. Okay, now with this, you know that this will cancel this. So what do we have here? Square root of 1 over 16. 1 over 4 times 4. Make sense? Then what? I want to rewrite this in a way that it will fit difference of 2 squared. It will become, so that I can present it as a difference of 2 squared. You know here, this is 2 squared here, right? So I can write 2ab here. All squared. Everybody is squared. 2ab squared means 4a squared b squared. Okay? Minus, open bracket, a squared plus b squared minus c squared. Then This all squared. Do you now see? It looks like difference of two squares. This is a square. This is another square. This is outside square. Difference of two squares. All right. So I will now express this um, as difference of two squares in just like what we did here. So we have 1 over 16 multiplied by, now difference of two squares, that is the first term plus the second term or minus the second term and the first term plus the second term. Does it make sense? So here it's going to be 2ab, which is the first term, plus a squared plus b squared minus c squared. Makes sense? We should use square bracket here. And 2ab again, but this time minus, God bless you, a squared plus b squared minus c squared. No, not square again. This is now difference of two square, you understand? All right. If that be the case, if I open this bracket here, I open the bracket, I will have 1 over 16 into bracket 2ab plus a squared plus b squared minus c squared. You agree? Okay. Multiplied by 2ab, open this bracket, minus a squared minus b squared plus c squared. Okay? But, okay. Now look at what I'll do. So as it is like this, let's bring it here. So it to be. So what we have there is the square root of 1 over 16, 2ab. Look at what I'll do. I'll rearrange this thing. Look at this thing. If I take a minus b all squared and a plus b all squared, if I want to square this thing, what will it give me? Square first guy, a squared minus 2ab plus b squared. And this one, a squared plus 2ab plus b squared. So I'm going to write that expression in terms of this. Look at it. You know, I can rearrange this so that it will look like a squared plus 2ab plus b squared. Okay, so I'm going to write it that way. A squared plus 2ab plus b squared. Make sense? Then that one too, I can write it, but this one is negative. So you know what I will do? I will rearrange it in such a way that if I rearrange this here to become 2ab minus open bracket, or no, let's put this first, that we will put c squared first. C squared is positive, right? Then c squared, we put minus a squared minus b squared plus 2ab, or plus 2ab first, minus b squared plus 2ab minus b squared. Okay, so see what I will do now. I will now put this minus outside, so that it becomes c squared minus a squared is positive. Now if you open bracket, it will give us this. But this time it was minus that should be here. Because minus times minus plus 2ab. Then what will I put here to give me minus here? Plus, God bless you, b squared. You see that it looks exactly like this. Does it make sense to you now? So I can write that here. We are not done with this one. There is a minus c outside. There is a minus c. There is a minus c here, c squared, right? Then open new bracket. Open another bracket. We have c squared minus a squared minus 2ab plus b squared. So you are still with me, right? So from here, this is from a plus b all squared, right? So this is a plus b all squared minus c squared. Is it making sense? Then 1 over 16 is still here. Our square root is still there. Alright. Then, so let's put in square bracket again. Then, here, c squared minus, what is this? Right? A minus b all squared. Good. Are you seeing the way I'm breaking down? Alright. So if that's the case, do you notice that we have we have another difference of 2 squares again? Difference of 2 squares again. Okay, but this one you have to open your eyes well so that you will not lose what I'm about to say now. Difference of 2 squares, that is the first term, that is a plus b, minus or plus, let's do minus first, minus the second term times the first term, a plus b, plus the second term. Is it clear? Okay. Then this one, the first term c minus the second term a minus b, and the first term plus the second term. Is this clear to you? All right. Difference of 2 squares. So I'll just take the first term minus the second term, and the first times the first term plus the second term. All right. So if that be the case, remember that this is 16, right? Now I can split 16 this way, so that I have this a plus b minus c over 2 multiplied by a plus b plus c over 2. Make sense? And here, let's open the bracket. C plus c minus a plus b over 2. Make sense? And here, c plus a minus b over 2. Now, you know it's still the same, right? Because it's 16. 2 times 2 times 2 times 2. Alright. You see this guy here, we are going to call it our semi-parameter. Why? Because our triangle is given like this. Remember, this is our triangle. This place was A, down was B and C, right? So this guy here, you know what? You know the meaning of perimeter. Perimeter means just add all the sides. That's not perimeter. Okay? So since we are just adding all the sides, and here we are dividing by 2. So we call it, yes, no, a semi-parameter because we are dividing by 2. It's not just perimeter. So a plus b plus c over 2, we call it S, which is our semi-perimeter. Is it clear now? But you'll soon notice that these other ones, they are a modified version of this. How? Do you know that this thing here, I can bring it out of this place. How do I do that? This will be a plus b plus c. This thing, I want to get this thing back. I'll do a plus b plus c, which is this, all over 2, which is S, isn't it? But minus this thing now, minus c. Do you know why I want to do that? So that I can get my minus c here. And how will I do that? See, to verify that, LCM is 2, so this becomes a plus b plus c, that is 2 into 1, 1 times everything. Then minus 1 into 2, 2 times this, 2c. By the time you do plus c minus this, is it not minus c? And you have what? A plus b minus c. Does it make sense now? Alright, so this will be, so therefore I can say that this thing, since I said this thing is S, so this place can be S minus c. Does it make sense? This place too, is going to be A plus B plus C. What is negative here? A, right? So it will be minus A again. All over 2 minus A. Let's test it. LCM is 2 again. So I have A plus B plus C. 1 into 2 times A. 2A minus 2A. You subtract, what will you get? Minus A. And you have B is positive. Minus A, C is positive, B is positive. Do you get it? So it means that it is this thing here is what? S minus A. Here, this one was what? S minus C. Then this one, since B is negative, from what I've been proving, then it means that we can also see that this also means S minus B. Alright, so what do we have? We have S. So we now have our formula becomes square root of S, which is this one, times S minus A times S minus B times S minus C. This one, the other is just, we are just trying to go in alphabetical order. Is it clear? So that's the proof for Heron's formula. And this is the formula for finding the area of a triangle. See you in the next video. Do well to subscribe to the channel and click the bell notification. If you want me to prove any other formula like that, you can let me know in the comment section. God bless you.